Hello. Hello, welcome. Guess what today is? Well, it happens to be 90s Hip Hop Day, but also it is Wednesday. Also, last day of class. Hello, yeah. Well, I do enjoy coming to this class. Yeah, I have some things for you today, and then I was also going to spend some time doing the final exam review, which I'm sure people are probably curious about. So let me jump into those slides. Before I begin, I just want to announce, like, for a fourth or possibly fifth time, that Natalie is no longer available as a TA. I am sorry if that's caused anybody any like hardship or problems. If you have something that you would like to, where you normally would have, kind of asked Natalie for help, feel free to reach out to me with an email. I'm happy to meet with you. I have met with a couple of people from Natalie's sections just to kind of advise them on their solutions to assignments or whatever. So just please let me know what I can do to help. Yeah, that's that. So Xin Chen will be there in 155 this Friday. I think, yeah. So, yeah. That's all I have for that. Anybody have any questions or anything like that? All right. Well, that's wonderful. So let me go ahead and kind of jump into these slides. So I have a short collection of slides. These slides do relate kind of directly to the stuff that we were talking about on Monday. That would be earlier this week. So one of the reasons I'm kind of this is me actually making something up. I'm calling them these algorithms everyday art algorithms. And the reason that I'm sort of coming up with that nomenclature is because these are probably the most commonly used algorithms by artists. Some of them are extremely recognizable, and some of them are less recognizable. So I think it's important for us to kind of like know what these are. I'm not really a good sort of like person for the YouTube age. Like, I don't have 5 reasons why you shouldn't use these algorithms. So I didn't put them in listicle form, I'm sorry. But mostly, I just kind of want everyone to be aware, if you're making code-based work, or if you're working with code as an artist, or even if you're looking at code-based art kind of out in the world, these are sort of really common kind of tropes. And number one is the idea of randomness. So obviously randomness is sort of like, there's the implementation of randomness that we have actually been using in P5, and then there's randomness as like a broader concept, right? So I think in general I'm talking about randomness as a broader concept. It's probably one of the most important sort of underlying kind of organizational schemes in even in digital art that doesn't use code, can probably rely on this idea of randomness or surrealness. What we're talking about, though, right now specifically is with the idea of pseudo-randomness and how it applies to code. So there's a really neat YouTube video here where it sort of chunks through like different ways of calculating randomness and how it's displayed. This is a good sort of recap of what that might look like. So is anyone here a math major? Anyone from math? I do actually talk to people from the math department occasionally. They exist. This is a really good example of the difference between true randomness and pseudo-randomness. So most of the C-based languages that we would potentially use in this course, or even that you would use as a human being studying code and art a little bit further, those are usually pseudo-random numbers. And to make a truly random number, it takes quite a bit more computing power, and it also, so it's slower, and it also, for most people, you won't sort of notice the artifact that creeps in with pseudo-randomness until you get maybe above a certain number of pixels. So if I were to just kind of, well, that's not going to work for me today. But basically, you can see that the cell that's actually generating the artifact is probably like 10 by 10 pixels. And so if you're using randomness as a sprinkle, meaning that you're kind of applying it in a very sort of judicious way, and it's only in certain things, then you may not ever notice this sort of artifacting that happens. The only reason that we're noticing the artifacting is because it's being applied to like a huge field of pixels, right? But I do think it's important to kind of realize that sort of pseudo-random functions are not maybe specifically truly random. And another sort of thing that we haven't actually tried in code, we've tried a couple of different implementations of randomness, but we have not actually tried the random walk, which is kind of a fun one to try. It's basically like where x and y, just you add to x and y some random amount, right? In this case, it's either, looks like it's either like 1 or 2 pixels, or it's between 1 and 5 pixels. And then you end up with this drawing that basically kind of draws itself through time. So as we talked about last class, we talked a little bit about randomness, and then we talked about how, oh, but wait, there's this thing that's sort of like randomness, but it's not randomness. It's like randomness's more sophisticated older brother. And that thing is called noise. Now, obviously, there's a sort of common sense, like in the English language, there is a word called noise, and that is, you know, what you hear on your headphones, maybe if it's not plugged in quite right, or if your Bluetooth is, you know, messing up, and you have some sort of, that's not the sense in which we're using the word. We're using noise to actually refer to a very specific algorithm called Perlin noise. And as you can see on the slide, it's used for lots and lots of different things, including sound, pixel-based art, 3D landscapes, and probably when I show you this slide, you'll recognize it most quickly from 3D landscapes. So this is what happens when you take this and you add 2 dimensions. You get down to that, which is a full sort of set of 3D geometry. Perlin noise is an incredibly flexible, and it's also a really easy way of generating terrain. So it's been a long time, by the way, since we've checked in with my game project that I have not had any time this semester to work on. But I will maybe take just a second to point out that I'm actually using a Perlin noise generator in Unity. So I will go ahead and just show you that for one quick second. So yeah, it's not up here. This is the sort of top layer. Yeah, all of this stuff down here is just straight up a Perlin noise generator. Sorry, I didn't spend too much time looking at that when I'm on the video, but yeah, that right there is 100% Perlin noise terrain. So it's something that, you know, you can use in a code-based level. Obviously, to like make a generator in Unity, it's much more like, how many Z units do you want your terrain to be? What color do you want your terrain? It's actually quite a bit easier than coding, but you know, you could if you wanted to. And so if we think about this as the one-dimensional Perlin noise that we were looking at via, let me find these examples really quickly. Woo. right here. Right, so this is the 1D Perlin noise that we looked at on Monday, just to kind of briefly recap. Oh. Sorry, did processing go down for a second? Oh my goodness. Well, maybe I'll come back to that. Has anyone else had any issues looking at these links? I mean, it looks legit. Okay, so basically it seems like p5.org is having some issues. So maybe we'll come back to that later. I guess I'm glad I showed you all that stuff on Monday. That's convenient. So in any case, what we were looking at was a series of repetitions of this sort of singular thing, this singular path. But if you do sort of take this and start repeating it, you can understand probably how you would get into building like a two-dimensional shape. In this case, this is called two-dimensional Perlin noise. And two-dimensional Perlin noise is used a lot for what are called height maps for generating textures in 3D environments. So when you start to see textures that look like this, that geometry is probably not directly sort of made into geometry. It's probably just that sort of two-dimensional image that then gets interpreted into that geometry. And so again, this is another place where you would see a lot of 2 and 3D Perlin noise, not just in terrain, but also in water simulations. And then lastly, we also see just a ton of Perlin noise in the generative art world. So there's a couple of images that I pulled that make use of Perlin noise in a really beautiful way. But I think in general, one of the sort of salient characteristics of Perlin noise as opposed to something like randomness is that in randomness, you can sort of see it's a hard edge. It's always one thing or the other thing. And in Perlin noise, you can sort of imagine these transitions, right? And you can imagine that sort of being less binary and being more sort of about the transition from one area to another. So we also talked a tiny bit about recursion last class, and these are some additional examples of recursion. Like Perlin noise, recursion is also used to simulate natural forms, but it tends to be natural forms that are more biological and less sort of terrain or landscape oriented, where Perlin noise makes awesome sort of rocks. Anything living or anything that kind of has this biological geometry is a good use for recursion. And here you can see, like a recursion forming a leaf. Recursion can also make a really nice tree pattern. Here's sort of like a shameless plug for, this might be, aside from Saul LeWitt, this might actually be the only work of art that I'm going to show you in today's lecture, or any of the lectures on code-based art that is actually not, in fact, code-based. This piece was presented at a digital media biennial in Frankfurt, maybe 5 or 6 years ago. And one of my colleagues was actually at this biennial, and this artist, John Powers, who has since had some infamy in the New York Times for other things, which I'll tell you about. Someone joked around that John Powers, his algorithm was take beer, make art. And and that basically he transformed these sort of styrofoam blocks. These are actually styrofoam blocks that he cut by hand based on a really simple algorithm that he set out for himself. So he's kind of like an outlier who's working in this really weird space of like humans who like to behave like machines. And it's a thing. It's a thing in the code-based world. And I think particularly for somebody to be working this way with simple materials like foam and a handsaw and a very sort of fundamental series of blocks. I think there were like 8 or 16 total blocks. It definitely sort of provokes an interesting conversation about what code actually is, right? And why are we even sort of thinking about this? So John Powers was actually in the news recently in the New York Times because I think he accidentally got trigger warning. I think he accidentally cut off his hand or several of his fingers in a shop accident. And so he's kind of like, was in the New York Times because he's kind of like rebuilding his artistic career and his life. So yeah, that's something to think about, for sure, for all of us. Health and safety, it matters. So here's another example of recursion, which is definitely like on the 2D end, and I'm going to show you just a few other recursion algorithms. This is circle packing. This is a really common algorithm that you'll see out on the interwebs, more circle packing. This is actually also circle packing, and this whole sort of like subgenre of code-based art where you take a photograph and replace the pixels with whatever small shapes, that's kind of totally a thing. That's like a formula for making generative art. And I'm not saying that it's a bad one, it's just one that you'll see a lot. And then lastly, we have the Voronoi algorithm, which is, people are starting to kind of calm down with it a little bit and not crazily overuse it. But the Voronoi algorithm is fundamentally based on triangle subdivision. So there's from the math perspective, it's called Delaunay triangulation. And it's also used a lot for sort of cellular metaphors, illustrating plants and animals at a kind of cellular level. It is definitely creeping into, like, this is a really cool video, by the way, if anybody wants to check it out. But it's definitely creeping into sort of like the visual culture of what we're seeing out there in design. And I think that in general, it's something that I would actually put Voronoi on the list of like extremely identifiable algorithms. And I guess maybe that's because it sort of reminds me, I don't know if anybody else is feeling strong crackle filter vibes, like from Photoshop, or crystalline filter vibes. It's very similar to that, and it does kind of have this like really identifiable look. And so again, it's just like, if you're thinking about, getting into making code-based work, these are the kinds of things that you kind of want to be aware of. I think in the right context, it can look amazing. It just, it might not be the greatest way to shade your circle that doesn't need to kind of like have anything else done to it. Yeah, so that's sort of just like a quick tour of all of the sort of things that are happening in code-based art and sort of things that are happening a lot in code-based art. I do want to spend a tiny bit of time today thinking about the final review. Dun, dun, dun. Let me go. Aha. I think I did it. Okay, excellent. So I'm gonna probably check like 500 times that I'm not actually showing the exam. Does anybody have any questions about the exam before I get going? Oh, thank you. Aha, yes.
So what kind of 3D modeler is Rhino? How do you random question?
Well, what do you think the answer to that question is?
If I were to guess, probably nerves.
Good guess. Yeah, well, we got that one taken care of, huh? So yes, what class of 3D modeler is Rhino? Did I make a study? I think I did make a study guide, by the way, for this. Oh, interesting. Okay, well, I'll post a study guide, but basically it's like every lecture thing. So I don't know if that would honestly really help you that much. But I will try to do that. Okay, so as I'm kind of going over these questions, yeah, there is a question about what's the subgenre of art that is often code-based, abstract, and focuses on the output or the algorithms of rule-based systems. So I'm pretty sure I just said that like 4 or 5 times. Did I? I think so. And so that's a question. So one of the reasons you might be wondering like why this exam is 20 points, but it has 18 questions. Obviously, there are multi-part questions. So some of the multi-part questions basically give you a chunk of P5 code, and then they have certain areas highlighted, and then I ask you things like, blah, 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 blah. What is the correct solution, or what is the correct thing to put inside this highlighted area in order to make this code work? Now, how would be the best way to accomplish that? You could ask your brain meats what you thought, you know, when you learned this stuff, and that would be a fine way to ask. If your brain meats are a little, like, you know, crunchy, you can also just take the code and paste it into the P5 editor and figure out what works. That is a completely valid approach to every single code question on this exam. In fact, I write the questions suggesting that you paste them into the code editor so that you can make sure that the solution is correct. So I just want to, because I'm kind of announcing that in class and, you know, putting it on the sort of lecture video, yeah, please use the P5 editor. That's like the best way to have success with those questions. I'm going to actually go ahead and go through the code questions in order because I think it makes more sense for me to do that. So some of the questions are asking you about the components of a for loop. And I know we talked about that at length in class. There are also some slides, coding for the arts, parts 1, 2, and 3. Those slide collections would be great tools, to look out for the code-based sections. So yeah, I would look towards those. But there is a question specifically about the 3 parts of a for loop. And there's, it might be good to sort of look towards the slides for that particular question, because I'm not asking you how the code works. I'm asking you what the components are called. And then going down to some of the rest of the code-based questions. Actually, there's two multi-part code questions. There are quite a few questions about Rhino. I'm sure you can imagine, we spent a lot of time with Rhino in the second half of the semester. So I do ask you a question about the hierarchy of form as I discussed it in class. So I'll give you a hint. It starts with points, and then we would go to curves or lines, then surfaces, polysurfaces, and finally that other thing. And there are actually a couple of questions about that type of shape in Rhino. I'll give you a hint. It rhymes with, oh man. I'm not sure if I can make that work. It rhymes with, interesting. Maybe I'll come up with another hint. It's not full of holes. Yeah. That's as close as I can get. But yes, there's a question right here about like what is basically, I'll just say it, what is a solid? And then that also is probably like a key to a couple of other questions, this idea of a solid. So there's a couple of questions where I kind of do some of our like day one type demonstrations in Rhino, where I say something like, hey, what this shape that we made by taking a thing and whooshing it around, what is that called when we do that? So yeah, there's a couple of those. And there are a couple of questions that relate to like the practice of coding in general. So what am I talking about? No, I'm not asking you about your keyboard or typing, but I'm maybe asking about what is it called when we take certain lines of code and make them usable or unusable. Yeah. And then, oh, I wish I had the screen on right now because I have my cat in this exam. So my, basically, I'm just going to give you all this one. So that's my cat, and he's sweet. And I could have included any image, so don't worry. I'm not quizzing you on how absolutely wonderful my cat is. The question has to do with the pixel size of that image. So I'm basically just asking you to download that image and then kind of tell me what the pixel size of the image is. And that is as close as we come to sort of cumulative review from stuff from the beginning of the semester. To be honest, the only reason that question is in there is because if you got through this class and somehow didn't know how to tell me the pixel size of an image, I don't know what I would do, but I would question my life choices. Okay, and then there's there's one question about p5.js and what its closest programming sort of language is. So it's like a family question. What language is p5.js based on? And that should be pretty straightforward to figure out because it's p5.js. That's a big hint right there. Let's see. So there are two questions about in P5. There's two questions that sort of differentiate what the setup function and what the draw function actually do. So as we kind of covered in class, the setup function runs only once during the runtime of the program, and then the other function does other things. So here's another couple of questions. Well, here's one question about P5. The question is, what is a variable? And that answer could be found definitely in the slides. A type of algorithm. Blah, 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 blah. Okay, and then it looks like there's 2 questions on the algorithms that I just introduced to you on Monday and this Wednesday, basically asking like what they're for. So one question asks, what type of algorithm is often used in 3D terrain generation? Right, we just talked about that. And there's another sort of, let me see. Okay, I've got 2 questions left. So there's a question about Rhino in the most general sense. So I just want everyone to kind of like wrap their brains around the fact that there is a process that we have been doing in Rhino called modeling, right? And that's where we're building the shapes and building the geometry to sort of create these forms. And then there's this second thing that we've been doing in Rhino that involves lighting, it involves texturing, it involves all of these other things. And for the most part, we have been referring to that in a certain way. And by the way, these are multiple choice, so like if it's not immediately popping to mind, like you're probably still good. Let's see. There's only one sort of art history question in this list of questions, and it is directly related to an artist who I actually mentioned at the beginning of this class. That was pretty much one of the only artists that we were talking about that made generative art without code. He was that guy, that wrote the instructions for how to make a painting and, with angles and lines and stuff. And so there's a question about that person. Does anybody have any additional questions or anything? No? Well, oh yeah, hi.
When you were talking about the setup function and like what other function, are you like referring to creating a function or just the other function that we use?
Yes, I am referring to the other one of 2 functions that you would use every single time you set up a sketch. Yeah, that's a good question. Any other questions? I'm sure y'all are going to do great. Well, I just want to say that I have really enjoyed coming to this class in this weirdo classroom. It's been super kind of like a really awesome change of pace. And yeah, it's been really great to kind of get to know a lot of you better. I've gotten to know some of you quite a bit better than I normally would because of Natalie being out. And that's actually been really, sad for Natalie, but it's been wonderful to kind of get down on the ground with y'all. I'm around, always up for a chat, and I hope to see you all around campus. Have an awesome summer. Yeah, thank you.